Hello, and welcome to Somniora Mind. I'm glad you're here. Here's a paradox worth carrying into tonight's drift. We have split the atom, mapped the human genome, and photographed a black hole from across the galaxy. And yet, right now, tonight, nobody on this planet can tell you why you feel like something instead of simply being something. So here are 3 quiet questions to fall asleep inside of. Why does time only ever move in one direction when the laws of physics themselves don't seem to require it? Why can a bird cross an ocean and land on the exact branch it left, using a sense we don't even have a name for? And is it possible that not knowing itself might be something closer to a gift than a failure? Here's where we begin, with a thought worth sitting inside of for a moment. Everything you can see, touch, and measure, every star, every rock, every person you've ever loved, accounts for only about 5% of everything that actually exists. Let that settle. Not 5% of what's interesting, 5% of what's there at all. The rest is quietly, patiently unaccounted for, doing its work in the dark, just outside the edge of what our best instruments can reach. Tonight isn't about fixing that. It's about resting inside of it. Get comfortable. Let your shoulders soften into whatever is holding you. Let your breathing slow into something long and unhurried. And when you're ready, let's drift together through some of the deepest, gentlest unanswered questions science has ever asked. Let's start at the very beginning, with the strangest question of all, not how the universe works, but why there's a universe here to work at all. It sounds almost too simple to be a real scientific mystery. Why is there something instead of nothing? But physics has never actually answered it. We can describe how the universe behaves once it exists, how gravity pulls, how stars burn, how galaxies drift. We can trace its history back almost 14 billion years to a hot, dense beginning we call the Big Bang. What we cannot explain is why there is a universe capable of having a history at all, why there are laws in place that allow anything to exist rather than nothing. Quantum physics offers a strange hint. Even what we call empty space isn't perfectly empty. It flickers with brief, fleeting particles that appear and vanish almost as quickly as they arrive. Some physicists wonder whether the universe itself emerged the same way, whether true nothingness is simply unstable, unable to hold still, always tipping over into something. Others imagine our universe as just one bubble in an endless foam of others, each with its own laws, its own history, its own quiet beginning. But even that idea only pushes the question backward. Why should there be a foam of universes instead of no foam at all? No telescope, no experiment, no collider will ever directly answer this one. It sits underneath every other question in science, holding up the entire structure without anyone quite knowing what it's standing on. Every atom in your body, every breath you're taking right now, rests on a foundation nobody has ever explained. And somehow, none of that needs to feel unsettling tonight. It can simply feel vast. A mystery so large it doesn't ask anything of you, only that you notice you're inside it. Let's move to the moment that started everything we can measure, because even that has a hole at its center. We can trace the universe's story back to a fraction of a second after it began, when it was smaller than an atom and impossibly hot. In that first instant, something called inflation seems to have happened, space itself stretching outward faster than light, in a burst so violent it shaped the entire structure of everything that came after. But what triggered that stretching? Why did it start? And just as strangely, why did it stop? Nobody knows. Our best instruments, orbiting telescopes, satellites built to read the oldest light in the sky, can show us snapshots of the universe just after this moment. None of them can look directly into the spark itself. We know the fire was lit. We simply don't know what struck the match. And once that fire was lit, it left something behind, a habit the universe has never broken. Time only ever moves forward. You remember yesterday, but never tomorrow. A cup falls and shatters. It never leaps back together into your hand. This one-way flow feels so natural that it's easy to forget how strange it actually is. At the smallest scales, the equations describing individual particles work exactly the same whether time runs forward or backward. Nothing in the fundamental laws demands a direction. And yet your entire life, every memory you have, depends on one. Physicists tie this to something called entropy, the tendency for order to fall apart into disorder over time. The universe apparently began in a state of remarkable, almost improbable order, and everything since has simply been the slow, patient unwinding of that order. But that only moves the mystery one step back. Why did the universe begin so tidy in the first place? Why should a cosmos ever start in a state precise enough to give time a direction to flow in? Nobody has a complete answer. You are, at this very moment, living inside one of the strangest unsolved questions in all of physics, and it feels like nothing more than the ordinary passage of a Tuesday night into sleep. Let's rest for a moment on the parts of the universe we can't see at all, because it turns out most of it falls into that category. When astronomers watch galaxies spin, something doesn't add up. Stars near the outer edges move far too quickly, fast enough that, by all the ordinary rules of gravity, they should be flung off into space entirely. Instead, they stay bound, held in place by something with mass, something with gravity, that no telescope has ever directly detected. We call it dark matter. It doesn't glow, doesn't block light, doesn't interact with our instruments in any way except through its gravity, a silent hand, holding galaxies together from the shadows. Some researchers think it's made of undiscovered particles. Others imagine ghostly things that barely touch ordinary matter at all. A few have wondered if it might be countless small black holes, formed in the universe's earliest moments. After decades of searching, enormous detectors buried deep underground, waiting patiently for a single dark matter particle to bump into a single atom, we still don't know. It makes up roughly 5 times more of the universe's mass than everything we can actually see, and it remains, essentially, a beautifully persistent shadow. And there's an even larger shadow beyond that one. In the 1990s, astronomers expected to find the universe's expansion gradually slowing down, the way a ball thrown into the air eventually falls back. Instead, they found the opposite. The expansion is speeding up. Some unknown force, woven into the very fabric of space, is pushing everything apart faster and faster with each passing age. We call it dark energy, though the name is really just a polite way of admitting we don't know what it is. It makes up close to 70% of the entire universe. Some think it's a fixed property of empty space itself. Others suspect it's something more dynamic, a field that shifts and changes over cosmic time. Its consequences are enormous. Whether the universe drifts apart forever into cold, empty silence, or something stranger happens down the line, depends entirely on the nature of this force we can measure the effects of but have never actually seen. 95% of everything, still mostly unread. And the universe keeps spinning gently through the dark anyway, unbothered by how much of itself remains unexplained. Let's turn now toward the strangest objects the universe has ever built, black holes, and the questions curled up quietly at their center. At the heart of a black hole, according to Einstein's equations, all of that immense mass collapses down into a single point of infinite density, a singularity. But infinity, in physics, is usually a warning sign, a place where the math is telling you it has reached the edge of what it can describe. Some physicists think the singularity is genuinely real, a place where the ordinary laws of nature simply stop applying. Others believe a deeper theory, one that finally merges gravity with quantum mechanics, will eventually replace that infinite point with something else entirely. A tiny loop, a compact core, an object we don't yet have a name for. The event horizon, that invisible boundary where nothing can escape, hides the answer completely from view. Whatever is really happening at the center of a black hole remains sealed away, beyond observation, beyond certainty, one of the most inaccessible mysteries science has ever run into. And there's a companion mystery tucked inside that one. When something falls into a black hole, it seems to simply disappear. But physics insists that information, the complete details of anything that ever existed, should never truly be destroyed. So where does it go? Stephen Hawking showed that black holes slowly leak radiation and, over almost unimaginable stretches of time, evaporate away entirely. If a black hole vanishes completely, taking its information with it, some of the most basic rules of quantum mechanics would break. If the information somehow escapes, smuggled out inside that faint radiation, nobody yet understands how. This puzzle has occupied physicists for decades, and it touches something much larger than black holes alone. The very question of whether the universe keeps a permanent record of everything that has ever happened within it, or whether some things really can be lost forever. That radiation itself, predicted back in the 1970s, has never actually been observed. In theory, a black hole should emit a faint, gentle temperature all its own, and lose mass so slowly it could take longer than the current age of the universe just to notice. But real black holes are usually surrounded by so much hot, chaotic material that this faint whisper gets completely drowned out. So we have a prediction that reshaped how we think about black holes, gravity, and quantum theory together. A prediction that, so far, remains beautifully, stubbornly unconfirmed. And then there's the strangest possibility of all, tucked into the mathematics almost as an afterthought. Some solutions to Einstein's equations suggest that a black hole's interior might connect to somewhere else entirely, a tunnel through space and time, sometimes called a wormhole, potentially leading to another region of the universe, or even another universe altogether. Nothing about this has ever been tested, and probably never can be, since nothing that falls into a black hole ever reports back. But the idea that some of the darkest, most destructive objects we know of might, in some hidden mathematical sense, also be doorways, that's a thought worth letting drift through your mind for a moment before we move on. Not something to solve tonight, just something to hold, gently, the way you might hold any beautiful uncertainty. Let's rest here a moment. Breathe in slowly for a count of 4. Hold it. Let it go, slower than it came. Somewhere out there, a black hole is doing exactly what it's always done, patiently keeping its secrets in absolute silence for longer than any of us will ever know. Let's drift now toward the very first stars, because even the beginning of starlight itself is still an open question. When the universe was young, it held nothing but simple clouds of hydrogen and helium, drifting through an otherwise dark cosmos. At some point, gravity gathered those clouds tightly enough to ignite the very first stars, enormous, blisteringly hot, living only a few million years before ending in tremendous explosions that scattered the first heavier elements across space, seeding everything that would come later, including, eventually, us. But we have never actually seen one. Not directly. They lived and died so quickly, so long ago, that their light has never reached us in a form we can recognize. Astronomers search for their fingerprints instead, faint chemical traces left behind in the oldest stars we can still observe, quiet echoes of a birth nobody witnessed firsthand. That same unanswered pattern shows up again, almost immediately, in an even stranger form. At the center of nearly every large galaxy sits a supermassive black hole, sometimes billions of times heavier than our sun. We understand, roughly, how black holes grow over time, slowly consuming gas, stars, even other black holes. But some of these giants already existed less than 1 billion years after the universe began, far too soon for that patient, ordinary growth to explain them. Did they form from the direct collapse of enormous primordial clouds, skipping the smaller steps entirely? Did they grow from the collapse of unusually massive first-generation stars? Or is there some mechanism we simply haven't discovered yet? These impossibly early giants remain one of the more persistent puzzles in the story of how galaxies came to be. And once galaxies did form, they took on a shape most of us picture instantly: the graceful, curling arms of a spiral, exactly like our own Milky Way. But why spirals should be so common is still not entirely settled. One idea treats the arms as a kind of density wave, similar to a traffic jam that stays in roughly the same place on a highway, even as individual cars move through it. Stars pass through a slower-moving region, bunch up briefly, and create the illusion of a fixed, permanent arm. Another idea points to gravity between neighboring galaxies, stirring stars into curved patterns over time. Simulations can recreate something spiral-shaped, but not perfectly and not consistently. So when you look at the Milky Way's own faint band stretched across a dark sky, you're looking out from inside one of astronomy's open questions, a shape both completely familiar and quietly unexplained. Let's listen, for a moment, to some of the strangest signals the universe sends us. In 2007, astronomers picked up an intensely powerful burst of radio waves lasting only a few milliseconds. More energy than our sun releases in an entire year, compressed into the blink of an eye. Since then, hundreds more of these fast radio bursts have turned up scattered across the sky. Some repeat, hinting at an ongoing source, possibly magnetars, neutron stars with magnetic fields so powerful they occasionally flare with tremendous violence. Others flash only once, suggesting something catastrophic and final, like the collapse of a dying star. No single explanation accounts for all of them. They arrive after traveling for billions of years, stretched and distorted by everything they've passed through, carrying clues about the very structure of the universe along the way. Brief, powerful shouts across an almost unfathomable distance, still waiting for us to fully understand who, or what, is speaking. There's a quieter kind of signal too, remarkably steady by comparison. Pulsars, the crushed, spinning remains of dead stars, sweep beams of radiation across space with a regularity so precise that when they were first discovered in 1967, scientists briefly wondered whether they might be a message from somewhere else entirely. They weren't, but their precision still astonishes. Some spin hundreds of times each second, keeping time better than our best atomic clocks, and occasionally they glitch, suddenly shifting their rotation speed in ways we still can't fully predict, hinting at strange physics happening deep inside their impossibly dense, superfluid cores. And then there are magnetars themselves, the source of some of the most extreme bursts of energy ever measured. A single second of activity releasing more energy than our sun produces in 100,000 years. What exactly triggers these eruptions? Whether sudden quakes rippling through a neutron star's crust or abrupt reorganizations of its magnetic field is still being worked out. High above all of this, cosmic rays, impossibly fast particles, rain down on Earth constantly, and the most energetic ones carry more punch than any particle accelerator humans have ever built could produce. Nobody knows exactly what natural process could accelerate a single particle to that speed. Somewhere out there, the universe is quietly running machinery more powerful than anything in our own laboratories, and it hasn't yet told us how. Let's drift, for a while, into the emptiest places the universe has ever built. Galaxies aren't scattered evenly through space. They gather into vast filaments and clusters, leaving enormous underfilled regions in between. Cosmic voids, some spanning hundreds of millions of light years, almost entirely devoid of galaxies. Simulations suggest gravity naturally pulls matter into filaments, leaving these gaps behind as a simple consequence. But some of the largest voids are bigger than those simulations predict, which raises a quiet, nagging question. Are they hinting at something new about how dark energy shapes the structure of the cosmos? Or are they simply rare, extreme outcomes of ordinary physics, playing out on the largest scale imaginable? A void is, in a sense, staring into nothingness at the grandest possible scale, one of the loneliest kinds of places that exist, and one of the least explained. And that same open-endedness reaches all the way to the final chapter of everything. The universe had a beginning. Will it also have an end? Several possibilities remain on the table, each depending on the true nature of dark energy. In one version, expansion continues forever, stars slowly burn out, galaxies fade, and the cosmos settles into a long, cold silence, what's sometimes called heat death. In another, expansion reverses, and everything collapses back together in a great crunch. In a third, dark energy grows stronger over time, eventually tearing apart galaxies, then stars, then planets, then atoms themselves, an ending called the Big Rip. Current observations lean toward continued expansion, but the fine details of dark energy remain too uncertain to say for certain which ending is waiting, or how many trillions of years away it might be. The story of everything doesn't have a confirmed final page yet. And somehow, that's all right. Most good stories don't reveal their ending early anyway. Let's leave the deepest cosmos for a while and drift closer to home, into our own solar system, where plenty of quiet mysteries are still waiting. For most of human history, we only ever saw one face of the moon. When spacecraft finally revealed the far side in the 20th century, it turned out to look strangely different, rugged and mountainous, almost entirely without the dark, smooth plains that cover the side we know so well. Why two faces of the same object should look so different is still debated. Perhaps one side was heated unevenly by Earth's gravity over billions of years. Perhaps an ancient collision reshaped one hemisphere and left the other untouched. No explanation fits perfectly yet. The moon should, by all logic, be symmetrical. It simply isn't, and it's been keeping that secret in plain sight the entire time humans have looked up at it. Farther out, Jupiter carries a storm larger than Earth itself, raging for at least 350 years and possibly much longer. The Great Red Spot spins on, fed by the planet's immense atmosphere, and yet in recent decades it has been slowly shrinking. Once wide enough to fit 3 Earths across, now barely wider than one. Why it formed exactly where it did, and why it has lasted so extraordinarily long when storms on Earth last only days, is still not fully understood. Meanwhile, far out near the edge of the solar system, Neptune, a cold, dim world receiving only a whisper of sunlight, hosts violent, fast-moving storms that shouldn't have nearly enough energy to exist. Something inside the planet itself may be driving them, but the details remain hidden beneath its deep blue haze. And even farther than that, past every planet we can see, astronomers believe an enormous, invisible shell of icy debris surrounds our entire solar system. The Oort cloud, thought to hold trillions of frozen fragments left over from its birth. We've never observed it directly. It's simply too distant, too faint, too small. We only know it exists because of the comets it occasionally sends streaking toward the sun, brief visitors carrying quiet evidence of a vast, unseen population we may never actually see for ourselves. Closer in, several icy moons appear to be hiding oceans of liquid water beneath their frozen shells. Europa, Enceladus, Titan, kept warm not by sunlight, but by the gentle, constant flexing of gravity from the massive planets they orbit. Some of these hidden oceans may hold more water than every sea on Earth combined. Enceladus actively sprays plumes of water and ice into space from cracks near its south pole, laced with salts and organic molecules. A direct sample from a sea we've never touched, hinting at chemistry that, here on Earth, would usually suggest the conditions for life. What drives those eruptions, and what, if anything, might be stirring in the dark water beneath, remains completely unknown. Titan, meanwhile, has lakes and rivers of liquid methane instead of water, methane that by all rights should have broken down under sunlight long ago. And yet it's still there, somehow being replenished by a process we haven't identified. And Mars, dry and frozen today, was once carved by rivers and lakes, maybe even entire oceans. Where all of that ancient water actually went, locked underground, lost to space, or perhaps still hiding somewhere beneath the surface, is one of the most important open questions in planetary science, because the answer might tell us whether Mars ever supported life at all. Let's slow down and let your breathing settle again for a moment. In gently, out even more gently. There is no need to solve any of this tonight, only to let it drift past, one quiet, unanswered question after another, like slow clouds crossing a dark sky. Let's turn now, for a while, toward the living world, because life on Earth keeps its own share of stubborn secrets. Most animals follow a simple, predictable pattern. Small bodies live short lives, large ones live longer. And yet nature keeps a handful of creatures that ignore this rule entirely. The Greenland shark drifts beneath Arctic ice for more than 4 centuries. Bowhead whales sing through frozen seas for over 200 years. Certain clams have been found alive after 5 centuries. Tiny naked mole rats live 10 times longer than similar-sized rodents, resisting the usual decline of old age almost entirely. Scientists have found scattered clues, unusually resilient proteins, efficient repair systems, slowed metabolisms, but no single explanation covers every case. Each of these creatures seems to hold its own private key to outlasting time. And so far, none of those keys have been fully copied. Some go even further than simply living long. The wood frog of North America freezes almost completely solid every winter. Its heart stops, its body turns rigid, and then, when spring arrives, it simply thaws and hops away, unharmed. Certain fish, insects, and the astonishingly hardy tardigrade can do something similar, surviving conditions that would instantly kill almost anything else, even the vacuum of space itself. Special molecules seem to protect their cells from the damage ice normally causes, but exactly how their hearts and brains survive months of complete stillness is still not fully mapped out. And size brings its own puzzle. Larger animals have vastly more cells, and therefore, in theory, far more opportunities for something to go wrong and become cancerous. And yet whales, some of the largest creatures that have ever lived, show remarkably little cancer over their long lives, a pattern known as Peto's paradox. Elephants seem to carry extra backup copies of certain protective genes. In whales, the explanation is still murky, perhaps unusually strong repair systems, perhaps a slower metabolism, perhaps something we simply haven't found yet. Somewhere in their biology may be a partial answer to cancer itself, still drifting, unclaimed, beneath the waves. Let's rest for a while on the animals that seem to navigate by senses we don't fully understand. Birds cross entire continents with uncanny precision, and part of their secret seems to involve Earth's own magnetic field. Though whether they sense it through tiny internal crystals or through some effect on proteins in their eyes that lets them see it as a faint pattern isn't fully settled. Monarch butterflies travel thousands of miles to a small patch of forest in Mexico, and the ones that return each spring are several generations removed from the ones that left the previous fall, meaning the butterflies making the journey have never made it before and somehow still know exactly where to go. Homing pigeons, released hundreds of miles from home under cloudy skies with no visible landmarks, still find their way back, guided by some combination of the sun, magnetism, and possibly even smell, in a way that's never been completely explained. There's something worth resting inside of in all of this. These creatures are moving through a version of the world we can barely perceive, reading invisible lines of force, following maps written in senses we don't have names for. Maybe that's a comforting thought to hold on to as you drift off. You don't have to see every path clearly to still find your way home. Some of the best navigators in nature never do either. They simply trust something quieter than sight. Let's rest for a moment on the very question of how life began at all, because for all we've learned about living things, that first spark is still missing. At some point, on an early, lifeless Earth, ordinary chemistry crossed a line into biology. Simple molecules somehow organizing themselves into something that could copy itself, gather energy, and begin the long, unbroken chain that eventually led to every living thing that has ever existed, including you, reading these words in the dark. Exactly how that happened is still unknown. Some researchers picture warm tidal pools on the early Earth's surface, cycling wet and dry, slowly concentrating simple molecules until something more complex emerged. Others look to the deep sea, toward hydrothermal vents where warm, mineral-rich water still rises from cracks in the ocean floor, offering both energy and structure that early chemistry might have used as scaffolding. A few even wonder whether some of the necessary ingredients arrived from space entirely, carried here on comets and meteorites, seeding an already fertile planet with a head start. Laboratory experiments have shown that many of the basic building blocks of life, simple amino acids, the pieces proteins are built from, can form fairly easily under the right early Earth-like conditions. But there remains an enormous, unexplained gap between having the right ingredients scattered in a pool of water and having something that qualifies as genuinely alive. Somewhere in that gap sits one of the most profound transitions in the entire history of the universe, and nobody has ever fully reconstructed how it happened. That uncertainty makes an even larger question harder to answer. If life could begin here, from ordinary chemistry given enough time and the right conditions, could it have begun elsewhere too? Some scientists suspect the ingredients for life might be common throughout the universe, and that given enough worlds and enough time, biology may spring up again and again. Others believe the leap from chemistry to biology may have required such an improbable, precise sequence of accidents that Earth could be exceptionally rare, maybe even alone. We don't yet have enough information to say which view is closer to the truth. Every answer we might imagine, that life is common, or that it's a singular, precious accident, remains, for now, equally possible and equally unconfirmed. Let's turn inward now, gently, toward the mind, because some of the strangest unanswered questions in all of science are the ones happening inside your own head, right now, as you listen. Every thought, Every memory, every quiet flicker of awareness seems to come from the brain. Scientists can watch electrical signals move across neurons, can switch consciousness off with anesthesia, can even track which regions light up when you look at a sunset or hear a familiar song. What none of that explains is why any of it should feel like something at all. A brain scan can show activity in the visual centers of your mind. It cannot explain why that activity arrives wrapped in the particular glow of gold and red you experience when you actually watch a sunset. Some researchers think consciousness emerges from information spreading widely enough through the brain. Others wonder if it's tied to very specific patterns of neural activity, or even whether awareness might be some deeper, more fundamental property of reality itself. None of these ideas fully explain the leap from ordinary matter to felt experience. Consciousness is, at once, the most familiar thing in existence. It's what you're doing right now, and the hardest thing in the universe to actually explain. Every night, that same mysterious mind builds entire worlds for you to wander through while you sleep. Nobody fully agrees on why. Some think dreaming helps the brain rehearse, replaying memories to strengthen the ones worth keeping. Others believe it helps process difficult emotions in a safe, unreal space. Still others suspect it's largely just the noise of a sleeping brain, loosely stitched into something resembling a story. What makes dreaming even stranger is its power. A nightmare can leave your heart racing even though you're perfectly safe in bed, and a good dream can leave you smiling through an entire day. We know the brain stays remarkably active during these hours. We simply don't know, with any real certainty, what all of that activity is actually for. Time itself behaves strangely inside your mind too. A moment of danger can feel like it stretches out endlessly. A joyful afternoon can vanish in what feels like a blink. Clock time never changes, but your experience of it constantly does. Some researchers think an internal sense of time speeds up under fear and slows under calm. Others suspect the mind measures time by how many new details it has to process, which might be why childhood summers, packed with novelty, feel endless, while familiar adult routines seem to disappear almost as soon as they begin. Nobody has the full picture. What's certain is that the seconds themselves never change, only how you carry them. And carrying moments is, itself, one of the deepest remaining puzzles. Your entire life is stored somewhere inside your brain, yet memories aren't kept like files in a cabinet. Their patterns spread loosely across many neurons at once, gathered and organized with help from a small structure called the hippocampus. Every time you recall something, that memory can shift slightly, reshaping itself before being stored again, which is part of why memories can change subtly over time, and why entirely false memories can sometimes feel completely real. Why some memories last an entire lifetime while others fade within days, and why a single smell can suddenly unlock a scene from childhood you hadn't thought about in decades, is still not fully mapped. Emotions carry their own quiet mystery too. Your heart races with fear, your stomach tightens with anxiety, tears well up with sadness, clearly involving both body and brain together. But whether emotions are ancient, hardwired survival tools, or something the brain constructs freshly each time out of memory, culture, and interpretation, is still debated. And creativity, that sudden spark of a finished idea arriving seemingly out of nowhere after hours of nothing, remains just as elusive. Some think it comes from the brain quietly recombining old ideas in new configurations. Others believe it requires stepping away entirely, letting a resting mind do work the conscious one can't. Neither fully explains why the answer so often seems to arrive all at once, fully formed, as if it had been waiting patiently the whole time for you to finally stop trying so hard. There are smaller, stranger flickers too. Déjà vu, that eerie sense of having lived through a brand new moment before, may come from a tiny misfire in how memory and perception line up, though nobody can predict exactly when or why it happens. The placebo effect can ease real pain and even calm certain physical symptoms using nothing but belief and expectation. Sometimes even when people know, consciously, that they're only taking a sugar pill. And every night, every single one of us gives up hours of awareness entirely for sleep. Behavior that, from an evolutionary standpoint, looks almost dangerously vulnerable, and yet appears in some form across nearly the entire animal kingdom. Sleep seems to help memory, clear away waste, restore the body, and steady emotion, and yet no single explanation accounts for why it's quite this essential, or why different species have found such wildly different ways of doing it. Let's rest for a moment here. Let your own breathing slow the way a mind slows on the edge of sleep. Not chasing an answer, just settling, gently, into the not knowing. Let's drift now toward the parts of being human that show up in every culture, everywhere, for reasons still not fully understood. Laughter crosses every language and every culture on Earth. Babies laugh before they ever speak a word. Some researchers think it began as an ancient signal of safety, a way of telling others that a threat had passed. Others trace it to the panting sounds of primates at play. But laughter goes well beyond any single explanation. It bursts out at relief, at awkwardness, sometimes even during sorrow, in ways that don't fit neatly into any one theory. Music moves through every culture too, despite having no obvious role in survival. Capable of making people cry, of calming newborns, of letting stroke patients who've lost the ability to speak still manage, somehow, to sing. And love, perhaps the most studied and least explained force in human life, floods the brain with familiar chemicals tied to reward and bonding, and yet none of that chemistry captures why it can arrive so suddenly, or last a lifetime in one person and fade in another, or make people risk everything against every ounce of reason they have. Humans cry for reasons that go well beyond biology, shedding tears during grief and during joy alike, in ways no other species seems to do. Storytelling appears in every known culture, wrapping lessons and memory inside imagined lives that were never real, for reasons still debated. Myths about floods, sky gods, and underworlds echo strangely across cultures separated by entire oceans, with no clear explanation for why such similar stories should arise independently, again and again, in places with no contact between them. Humans cooperate with total strangers in ways most other species never do, donating blood, sharing resources, occasionally risking their own safety for people they'll never meet, guided by something that goes beyond simple calculation or expected reward. Curiosity itself, the very drive pulling you through this list of mysteries right now, pushes us to study galaxies billions of light years away and decode ancient languages with no practical use at all, and where exactly that restless hunger to understand actually comes from is, itself, still not understood. Even language, the very thing making it possible to share any of these mysteries with each other in the first place, has a beginning nobody has ever pinned down. At some point, distant ancestors made a leap from simple calls to full, structured language, complete with grammar and the ability to describe things that aren't even present, to plan, to imagine, to dream out loud. Exactly when or how that leap happened is lost entirely to time. We can only listen to language now, marveling quietly at the mystery still folded inside every sentence we speak. Let's turn briefly toward the ground beneath your feet, because Earth itself keeps a few secrets of its own. Every so often, a volcano erupts with catastrophic force, releasing energy on a scale that can alter climate across the entire planet. And scientists still can't reliably predict which ones will do this, or exactly when. Somewhere, a stress deep inside the crust flips a switch from ordinary rumbling into true disaster, and we haven't fully mapped what determines that switch. Beneath us, Earth's crust is broken into massive plates that drift, collide, and grind against each other. Plate tectonics, a process that shapes our mountains, our earthquakes, our entire habitable surface, and yet doesn't seem to exist anywhere else in the solar system. Why it began here, and not on similar rocky worlds like Mars or Venus, remains genuinely unclear. And water itself, covering most of this planet, filling oceans and clouds and rivers, has an origin still under debate. Some of it possibly delivered by ancient comets and asteroids, some of it perhaps present from the very beginning, rising slowly up from deep within the planet over billions of years. Even something as familiar as a glass of water carries, quietly, an unsolved question about where it actually came from. Let's rest for a while longer on the body itself, because aging, something every living thing experiences, is still, at its core, only partly understood. Skin wrinkles, hair turns gray, strength fades, and eventually the body begins to fail. Science has pieces of an explanation, but not a complete one. One idea points to the tiny protective caps at the ends of our chromosomes, which grow shorter every time a cell divides, until division simply stops. Another blames slow accumulated damage, oxygen and other byproducts quietly corroding cells over the decades, leaving small scars that build up over a lifetime. A third view treats aging as an old evolutionary trade-off, energy spent early on reproduction rather than long-term repair, leaving the body more vulnerable later on. And yet nature keeps offering exceptions that don't fit neatly into any of these ideas. Certain turtles and fish show almost no visible signs of aging at all. Some jellyfish appear able to revert back to an earlier stage of life entirely, sidestepping decline in a way no other creature manages. Why some living things resist aging so completely while most of us don't is still, even now, an open question, one that, if answered, could reshape medicine as thoroughly as anything in its history. And there may be an upper boundary to it all, though nobody has confirmed exactly where that boundary sits. The longest confirmed human life ended at 122 years. Some researchers believe this points to a genuine biological ceiling, a point beyond which the body simply can't repair itself quickly enough to continue. Survival rates do seem to drop sharply after about 110. Others argue there's no strict maximum at all, only ever-rising odds of frailty and chance stacking up against you. What makes this especially puzzling is that average life expectancy has climbed enormously over the last century, thanks to medicine, nutrition, and hygiene, and yet the maximum lifespan has barely moved at all. Almost no one, anywhere, in any era of modern record-keeping, has lived past about 115. Whether that number is fixed forever, or whether it can eventually be pushed further, remains completely unresolved. There's a different kind of resilience worth resting on too, the strange, quiet gift some animals have for rebuilding themselves entirely. A salamander that loses a limb simply grows another. A starfish that loses an arm slowly rebuilds it. Certain worms can regenerate an entire new body from just a single fragment. Humans share many of the same genes involved in this process, and yet, for reasons still not understood, our own bodies rarely use them the way a salamander's does. Researchers studying these creatures have found that cells near an injury seem to reset themselves, rolling backward into something like an early embryonic state, before carefully rebuilding muscle, bone, and nerve in perfect order. If we could ever unlock that same trick in ourselves, it could mean regrowing damaged hearts, healing spinal injuries, restoring lost limbs entirely. And yet the complete blueprint for how regeneration actually works remains hidden, belonging, for now, only to the salamander, the starfish, and a small handful of other patient, quietly miraculous creatures. Let's drift, for a moment, towards something a little larger than any single body, the rise and fall of entire civilizations, and the forces behind that pattern that are still debated today. Across history, great civilizations have grown, flourished, and eventually collapsed. The Maya, the cities of the Indus Valley, ancient Mesopotamia, Rome. Why they follow this same arc again and again, in different eras and different corners of the world, is still not fully agreed upon. Some point to climate shifts, prolonged droughts, and natural disaster. Others emphasize war, internal corruption, or the slow exhaustion of resources a society had come to depend on. Still others believe there may be a deeper, more universal rhythm to it, a pattern of growth and eventual decline that simply repeats, regardless of time or place, almost like a kind of civilization scale biology. What's especially striking is how quickly a collapse can unfold, considering how slowly a civilization usually builds. Great cities, once thriving, get abandoned. Entire bodies of accumulated knowledge quietly vanish. Generations pass into silence, leaving only ruins and questions behind. We live, right now, inside a vast, complicated society of our own, built on the assumption that it will simply continue. History gently reminds us that nothing has ever been guaranteed to, and it still hasn't fully explained why. Let's rest for a while longer on the question of whether we're truly alone out there, because for as long as anyone has looked up at the stars, that question has refused to close. Astronomers have now confirmed thousands of planets orbiting other stars, many of them small and rocky, some sitting in the narrow band of distance from their star, where liquid water could plausibly exist. But being in that zone doesn't automatically make a world truly habitable. A planet also needs the right kind of atmosphere, a magnetic field strong enough to shield it from harmful radiation, and long-term stability in its orbit and its climate. Some of these distant worlds are almost certainly scorched by radiation from an unruly star. Others are probably locked in permanent cold, too far from any real warmth. Even icy moons, hiding oceans far from any star's light at all, might turn out to be habitable in their own way, though we can't yet measure their hidden waters directly. The galaxy could be quietly rich with livable worlds, or those worlds could be rare and precious exceptions. Right now, we genuinely can't say which is closer to the truth. And so the oldest question of all remains exactly that, a question. We listen with radio telescopes, tuned toward the faint possibility of an artificial signal arriving from somewhere else. We send probes to nearby moons and planets, searching their soil and their ice for the faintest chemical trace of life. We study the thin atmospheres of distant worlds, looking for the subtle fingerprints certain gases would leave behind if something living were breathing them out. So far, in every direction we've looked, the answer has been silence. It may be that life turns out to be common, but that intelligent, technological civilizations are rare, or brief, or simply too quiet to notice. It may be that life itself is rare at every single level, and that we are a genuine, singular accident. Or it may be that life is everywhere, simply separated from us by such enormous distances, or such unfamiliar forms, that we haven't yet learned to recognize it. Are we a lonely spark in an otherwise empty universe, or one voice in an enormous chorus we simply haven't learned to hear yet? Until real evidence arrives, this oldest of questions stays open, the way it always has. Let's pause here for the tagline that's become a little ritual of its own on this channel. Because if you'd like more of these slow, gentle drifts through the strange and the vast, you're always welcome to come back another night. One quiet mind at a time. That's really all this is for. Now, back into the dark, for just a little while longer. Let's rest on something a little stranger and more delicate. A handful of natural phenomena that have puzzled careful observers for centuries and still do. During certain earthquakes, witnesses have reported glowing lights in the sky, flickering blue flames near the ground, sudden flashes resembling lightning, strange orbs hovering silently near fault lines. These earthquake lights have been described for hundreds of years, and modern cameras have now captured genuine footage confirming they're real. What actually causes them remains unclear. One idea suggests that stressed rock, deep underground, can release electrical charges as an earthquake builds, sparking light in the air above. Another proposes that shifting tectonic forces ionize gases near the surface, causing them to glow faintly on their own. Not every earthquake produces this effect, and when it does appear, it varies enormously from one event to the next, which makes the phenomenon frustratingly difficult to study carefully. In some documented cases, the lights have appeared just before the shaking begins, leading to quiet speculation about whether they might someday serve as a kind of early warning. For now, they remain one of the eerier reminders that the ground beneath us may hold forms of energy we haven't fully learned to read. There's an even stranger, more elusive cousin to that phenomenon. For centuries, people described a glowing orb of light, floating silently through fields, or occasionally drifting indoors through an open window, sometimes lingering for several seconds before vanishing or bursting with a small pop. For a long time, this so-called ball lightning was dismissed as myth or a trick of the eyes. In recent decades, credible sightings and even a few scientific recordings have suggested it's a genuine, if extremely rare, physical event. What it actually is remains unsettled. Some researchers picture a small pocket of plasma trapped briefly by electromagnetic fields. Others imagine vaporized minerals glowing after being struck by ordinary lightning. Still others propose specific chemical reactions occurring in the air. None of these explanations quite covers every reported case, including reports of the glowing orb passing through solid windows without breaking them, behaving less like ordinary matter and more like something we don't yet have the physics to describe. Let's rest for a moment on something even closer than the mind, the body itself, and the enormous hidden world living quietly inside it. Your body is home to trillions of microorganisms, bacteria, fungi, and other tiny passengers, living mostly in your gut, but scattered across your skin and throughout your body as well. Altogether, they may outnumber your own human cells or come close to it, depending on how the counting is done. This hidden community, called the microbiome, does far more than simply exist alongside you. It helps digest food you couldn't break down on your own, produces certain vitamins, trains your immune system to recognize friend from threat, and increasingly appears to influence mood and even behavior through a constant, quiet exchange of chemical signals with your brain. Exactly how deep that influence goes is still being mapped. Some researchers suspect the state of this inner ecosystem could play a role in conditions ranging from anxiety to autoimmune disease, though the full mechanisms connecting gut and mind remain far from settled. In a very real sense, you are not one single organism drifting through the world. You are a walking, breathing collaboration, a community of trillions, and most of what that community actually does for you, moment to moment, is still happening just outside the reach of full scientific understanding. there's a related mystery even closer to the surface. Every person carries a unique combination of genes, and yet identical twins, who share essentially the same genetic code, can still grow into people with different health outcomes, different personalities, sometimes even different susceptibilities to disease. Something beyond the genetic code itself appears to shape how those genes get expressed. A layer of chemical switches sitting on top of your DNA, turning certain genes up or down in response to diet, stress, environment, and experience. This field, called epigenetics, suggests that your biology isn't simply fixed at birth, but continues responding to your life in ways that can sometimes even be passed down to your children. Exactly how much of this influence lasts, and exactly how it's controlled, is still an active and rapidly evolving area of research. Your body, it turns out, is not a finished blueprint. It's something closer to an ongoing conversation between your genes and everything that has ever happened to you. Let's drift, for a while, toward the long, unfinished story of human exploration itself, because even our own outward reach into the universe carries open questions. Every mission we've sent beyond Earth, every rover crawling across Martian sand, every probe slipping past the icy moons of Saturn, every telescope drifting 1,000,000 miles from home to stare into the deepest dark, has answered old questions only by opening new ones. We've learned that Mars once had rivers, and we still don't know exactly where all that water went. We've learned that Europa and Enceladus likely hide oceans, and we still don't know what, if anything, might be swimming inside them. We've mapped the surface of Pluto in stunning detail and found mountains, glaciers, and a hazy blue atmosphere nobody expected on a world that distant and that cold. Each answer, without fail, seems to generate at least one more question behind it. That pattern isn't a flaw in how science works. It may be closer to the entire point. Every new instrument we build, every new mission we launch, doesn't just fill in a gap in the picture. It usually reveals how much larger the picture actually is than we assumed before. The James Webb Space Telescope, capable of catching light from galaxies far older and fainter than anything seen before, has already found some galaxies more massive and more fully formed earlier in cosmic history than our models predicted was possible. Rather than simply confirming what we expected, it has quietly rewritten a few chapters of the story we thought we understood. That's not a setback. It's closer to what curiosity has always looked like, at every scale. A series of doors, each one opening onto a hallway holding several more. Let's rest for a while longer on the strange, layered nature of scientific knowledge itself, because even the history of discovery keeps surprising the people making it. 2 centuries ago, nobody knew atoms existed as more than a philosophical idea. A century ago, nobody knew galaxies existed beyond our own, or that the universe was expanding at all. 50 years ago, nobody had confirmed a single planet orbiting another star. Each of these discoveries once sat exactly where today's mysteries sit now, just past the edge of what instruments could measure, just beyond what anyone could confidently claim to know. And each one, eventually, moved from mystery into simple, settled fact, taught now in classrooms without a second thought. It's tempting to imagine science as a fixed body of knowledge with a shrinking list of gaps left to fill in. The actual history looks more like a coastline, endlessly revealed as the fog lifts, only for a wider, more complicated shore to appear just past it. There's no evidence the fog is close to lifting entirely, and there's a strange kind of comfort in that. It means someone, somewhere, might spend an entire career on exactly one of the questions you've been drifting through tonight, and might still be working on it their whole life. And that will have been enough. Understanding doesn't require finishing. It only ever requires continuing. Let's rest for one more moment on the very instruments we use to look for answers, because even those carry their own quiet limits. Every telescope, every particle detector, every deep-sea probe we've ever built can only show us what it was designed to measure. A radio telescope reveals nothing about visible light. An optical telescope is blind to the faint background hum of gravitational waves. For most of history, we could only see the universe in the narrow slice of light our own eyes happened to detect, and every new instrument built since has been, in some sense, an attempt to grow a new sense we were never born with. Each new type of detector we've invented has revealed a version of the universe that was always there, simply invisible to whatever came before it. That raises a quiet, humbling possibility. There may be entire categories of phenomena happening around us right now, quietly, constantly, that no instrument we've built yet is capable of detecting at all, not because they're rare, but because we haven't yet built the right kind of eye to see them. Some of tonight's deepest, most stubborn mysteries may not be waiting for a cleverer theory. They may simply be waiting for an entirely new sense we haven't invented yet. Let's slow down again and rest for a while in physics itself, because even our most trusted equations carry mysteries folded inside them. Mathematics, a system humans invented out of numbers and logic, describes the universe with an accuracy that borders on eerie. Equations written on paper have predicted black holes and radio waves long before anyone ever observed them directly. Why abstract symbols should map so precisely onto the real, physical world is still not agreed upon. Whether math is something we discovered, already woven into the structure of reality, or something we built, shaped by evolution to fit the patterns we happen to notice. Meanwhile, the fundamental constants running underneath every equation, the speed of light, the strength of gravity, the exact charge carried by an electron, are measured with extraordinary precision, and yet nobody knows why they carry the particular values they do. Adjust them even slightly, and stars might never form at all. Some suspect these numbers are simply an accident. Others imagine countless other universes, each with its own different settings, and we happen to live in the rare one where the dial landed somewhere that allows for stars and chemistry, and eventually, quiet nights like this one. Even randomness itself remains an open question. At the smallest scales, a single particle can behave in ways that seem genuinely unpredictable, appearing here or there, decaying now or later, with no discoverable cause behind the choice. Einstein famously resisted this, insisting some hidden order had to be waiting underneath. Decades of careful experiments since then suggest he may have been wrong, that some events in the universe really might be irreducibly, fundamentally random, uncertainty built directly into the fabric of reality rather than simply hiding a deeper order we haven't found yet. And in the earliest instance after the Big Bang, matter and its opposite, antimatter, should have formed in exactly equal amounts, enough that the two should have annihilated each other completely, leaving nothing behind at all. And yet, here we are. Some tiny asymmetry tipped the balance ever so slightly in favor of matter, and that faint tilt is the entire reason anything exists to read these words tonight. We've measured small differences between matter and antimatter in the laboratory, but nothing large enough yet to fully explain such an enormous, fortunate imbalance. Somewhere in the earliest fractions of a second of cosmic history lies the actual reason there is something instead of nothing, and it remains, for now, one of the most important unsolved riddles in all of physics. Even mass itself, something that feels as solid and self-evident as anything could, turns out to rest on a partially hidden foundation. The discovery of the Higgs boson in 2012 confirmed that an invisible field fills the entire universe, and that particles gain mass by interacting with it, the way a swimmer feels resistance moving through water. But why that field exists at all, why it has the particular strength it does, and why different particles interact with it so differently, is still unexplained. And at the very smallest scales imaginable, physics may not even be smooth. Some theories suggest space itself could be built from tiny, indivisible units, more like the pixels of a screen than an infinitely divisible line. A texture to reality so fine that no experiment has ever come close to detecting it directly. Whether the universe is ultimately continuous or, in some strange sense, granular, remains an open and genuinely thrilling question. Underneath all of it sits perhaps the largest unanswered question of them all. The laws of physics, elegant and precise as they are, didn't have to be this way. They could have been different. A universe where stars never form, where matter drifts apart instead of gathering, where nothing like a night sky or a mind to look up at one ever comes into being. Why this particular set of laws, and not some other, is something no theory has managed to explain. We can describe the rules with extraordinary precision. We still don't know why these rules, of all the possible rules there could have been, are the ones written into existence. Let's rest for a while on one more open question, closer to home than almost anything else tonight: the tools we've built to help us think. In recent years, machines have begun doing something that used to belong only to living minds: recognizing patterns, generating language, even producing something that looks, from the outside, a little like creativity. And yet, the researchers building these systems will often tell you, quite openly, that they don't fully understand everything happening inside them. A large enough network of simple mathematical connections can develop behaviors nobody explicitly programmed into it, abilities that seem to simply emerge once the system grows complex enough, in ways that are still being studied and explained after the fact rather than predicted in advance. Whether anything happening inside a system like that resembles understanding in any real sense, or is something else entirely dressed up to look that way, is a question science doesn't have a settled answer to yet either. It's a strange, very modern mystery, sitting right alongside a fair number of ancient ones, a form of not knowing we've built for ourselves, on purpose, simply by being curious enough to try. Let's slow all the way down now and gather the enormous, gentle picture we've built together tonight. We drifted from the very question of why anything exists at all, through the fire that lit the universe's first moments, past galaxies built from invisible matter and pushed apart by an energy we still can't name. We rested beside black holes holding their secrets in perfect silence, and passed through storms that have raged for centuries on distant planets, and past icy moons quietly hiding oceans no human has ever touched. We wandered through ancient creatures that seem to have found their own private ways around time itself, past birds and butterflies reading a map written in a sense we don't have a name for. And then we came home, gently, into the strange, familiar mystery of your own mind, the dreams you build every night, the memories you carry without knowing quite how, the love, the laughter, the tears that have never fully been explained and probably never fully need to be. Maybe that's the real thread running underneath everything tonight. Not that science has failed to answer these questions, but that it hasn't needed to, not yet, in order for any of it to still be beautiful. A dream doesn't need a fully solved purpose to feel meaningful while you're inside it. A song doesn't need a complete neurological explanation to bring you to tears. A night sky doesn't need every one of its mysteries resolved in order to be worth looking up at. Mystery, it turns out, isn't the opposite of understanding. It's simply understanding that hasn't finished arriving yet. And there is nothing at all wrong with resting comfortably inside of something unfinished. So let your own thoughts do the same thing tonight. Let them stay a little unresolved, a little open-ended, a little unanswered, the way the universe itself does. There's no need to close every loop before you sleep. No need to solve anything tonight at all. Just let your breathing slow, let your body grow heavy, and let yourself drift gently into all of that soft, patient not knowing. The same not knowing the entire universe seems to rest inside of, quietly, contentedly, without ever once losing its shape. Rest now. You've earned it. Good night.